Autodesk Moldflow has the ability to run a cooling analysis in both gas-assisted injection molding and two-shot overmolding. Part cooling effects can now be taken into account in filling and warpage for both the first and second shot component. In the overmolding process, the mold plate rotates after the first shot or substrate is done and carries the part over to the second shot position, where the second shot is molded over the first shot. This occurs simultaneously as another substrate is being molded. The rotary motion allows for a continuous two-shot manufacturing operation. In prior releases of Autodesk Moldflow, we could simulate the overmolding process with a fill, pack, and warp analysis. What was missing was the ability to include cooling in the analysis. Cooling can have a considerable impact on part warpage, and until now, the cooling effects could not be calculated or accounted for. The transient thermal behavior of an overmolding mold is quite complex. The two mold halves will rotate, changing its mating half every molding cycle. We can now see the thermal history of the first shot on the second shot. Such mold temperature history will be used as a boundary condition in subsequent analyses to provide more accurate solutions, especially regarding part deflection or warpage. Cooling is also available for gas-assist injection molding. The temperature of the mold and the gas bubble are dependent upon each other. The size of the bubble will affect the heat load of the tool. Using the cooling analysis sequence allows the user to consider their cooling system when simulating 3D gas assist. The resulting shape of the gas bubble in the part considers all of the cooling effects in the mold and the relevant cycle times. Simulation can now be used to evaluate and optimize cooling for both the two-shot overmolding process and gas assist injection molding, and the corresponding effects on the final plastic part can now be considered.